So in this problem, the problem is giving us a paraboloid for z equal to x squared plus y squared, and a sphere x squared plus y squared plus z minus 4 to the power 2 equal to 16. And it's asking to find the triple integral on this the area enclosed by them. That's the area of the one scoop ice cream bowl and 1 scoop ice cream bowl. And then basically it's asking you to find that in cylindrical coordinates. What I think is, well, I see a z surface down here and I see a z surface up there. So I start thinking about basically going about the cross sections R and Z. And then if I rotate this around, that's this cross section, which is looking like that, halfway here, halfway there. So that's the lower part, that's the upper part. And then rotating this 2 pi is going to give me the entire solid, basically. So let's set this up. First of all, let's convert the f of x and y and z, which is x squared plus y squared into cylindrical. This is, we should know it's equal to r squared. So I'm setting up the triple integral, r squared times, don't forget Jacobian, r, and I decided that this direction is z simple. So I'm going to go dz, then I go dr and d theta, right? So z starts from the lower one, and let's convert the lower one into cylindrical. That is just 4z is equal to r squared, or z equal to r squared divided by 4. That's a lower bound for z. R squared divided by 4. And then go to the higher one. Let's convert the higher. So it's x squared plus y squared, which is r squared, plus z minus 4 to the power 2 equal to 16. Isolate z. Z minus 4 to the power 2 is 16 minus r squared. So z minus 4 is equal to plus minus square root of 16 minus r squared. So over here, and if I solve, I get z equal to 4 plus minus square root of 16 minus r squared. It's very quickly, it becomes very quickly obvious. I want the upper part of the sphere, so I need a plus 1. And so plus of that goes over here. Now, there's one more computation I need to do. So that was the computation of finding the sphere in terms of z equal to the upper part of the sphere, because it's not. And then the other computation is to find r. And theta, I know. This thing can move in and out as long as you move it with d theta. The theta can move in and out. The other two are the ones that you have to compute. With dr, I know it starts from 0. I just have to find this point. And how do I find that point? By basically, now that I have the lower part is z equal to r squared over 4, and upper part is the other one, I can set them equal to each other to find the intersection. What is the intersection at that point? And that is 4 plus square root of 16 minus r squared. And so multiply through 6, r squared is equal to 6, right? Right. Is equal to 16 plus 4 square root of 16 minus r squared. It's getting there, but it's not quite what I want. Let's try to isolate square root. And I get this. Let's go to power 2. So get rid of the square roots, and I can see things better that way. When you're going to power 2, this goes to power 2, that goes to power 2, right? I'm going to power 2. And so 16 times 16 minus r squared, right? And now there are ways of doing this, and now I can see that, wait, r squared minus 16 is really 16 minus r squared to power 2, because this and this are, the r squared minus 16 is just negative 16 minus r squared. And as long as I'm going to power 2, the negative disappears, right? And so the negative part disappears, and I end up with, so r squared minus 16 equal to negative 16 minus r in parentheses to power 2, and negative to power 2 is going to be positive. And so now I will have 16 minus r squared to power 2. This is a side work, equal to 16 times 16 minus r squared. Here I can say either 16 minus r squared is equal to 0, or I can cancel it. If it's not 0, I can cancel it. If I cancel it, I end up with this. This part gives me r is equal to plus minus 4, which is minus, doesn't make sense, so positive 4. This one gives me r is equal to 0. R equal to 0, I know it's the lower one. It makes sense that in some ways that this that we end up with the extraneous solution that is the bottom down there. But r equal to 4 is obviously right there. And then you take the antiderivative from there.